Hello everyone, welcome back. Today's topic is Euler's method. So what is Euler's method? It is part of differential equation. So in Euler's method, we find a numerical solution of any differential equation without even solving it. What does it mean? So before that, let's appreciate the work of this gentleman, Leonhard Euler from Switzerland. He was the one who came up with this method. So, going back to Euler's method. So, Euler's method is a method that is used to estimate or generate a numerical solution to an initial value problem. So, when you are given any differential equation, without solving the equation, we find value of y for a given value of x. So, if you recall in other methods of solving differential equation, whether it was variable separable or homogeneous or linear differential equation, we used to solve differential equation, right? Out here we won't be solving the differential equation. So what do? We just find the value of y for a given value of x without solving the differential equation. So what is the big idea? What is the working rule here? So when you are given a differential equation, write it in the term dy upon dx is equal to function of x and y with a given initial value. You will always be given an initial value problem. That is, you will be given a value of y for some value of x. Using Euler's method, without solving this equation, we can find the value of y corresponding to x. Let's explore this with the help of an example. So have a look at this example. Dy upon dx is given x plus y and y0 is equal to 1, and use Euler's method with a step size of 0.2 to find an approximate value of y1. Now, what is the step size? So in Euler's method, we use recursive formula. Now, what is the recursive formula? In recursive formula, we find the value of a variable in terms of its previous value. That is recursive formula. We'll explore more in detail soon. And what is the step size? Step size is we go in small steps to work out these values. Like in this question out here, you've been given y0 is equal to 1 and step size is 0.2. So when x is 0, y is 1. So the next value of y that we'll find is after taking a step of 0.2, means we will find the value of y corresponding to 0.2. Next value will be 0.4, next value 0.6, next 0.8, and then finally value of y when x is equal to 1. How do we do this? Let's start. Here step size is 0.2, so we move from 0 to 1 in small steps of 0.2. How do we do this? Let's say these are your steps. So we start from 0, then 0.2, then 0.4, 0.6, 0.8 and 1. Now these are values of x we will be working with. Now, what are the values of y that you need to find? To find the value of y, you've been given that when x is 0, y is equal to 1. This is one of the values given to you, value of y. And for the other values of y, we use this recursive formula. Let's understand this first, then we will work. So yn plus 1 means any value of y is equal to previous value of y plus h times dy upon dx at the previous value of x and y. So in this case, to find the value of y when x is 0.2, then that value will be the value of y when x is equal to 0 plus h times dy upon dx means x plus y at when x is 0 and y is 1. And what is this h? This h is the step size. So in this case, it is going to be 0.2. Okay? So let's work this out. So this was the question. Since the step size 0.2, so next x value will be 0 plus 0.2, that is 0.2. And what will be the next y value? This will be 1. That is the previous value of y plus h, which is 0.2 times dy upon dx at which point 0, 1. Dy by dx is x plus y. So this becomes 1 plus 0.2 times x plus y means 0 plus 1, which is 1.2. So value of y is 1.2 when x is equal to 0.2. Then next value will be x is equal to 0.4. So what will be the value of y at 0.4? That will be previous value, that is 1.2, we just calculated, plus step size 0.2 times dy upon dx at the previous value, means when x is 0.2 and y is equal to 1.2. So when you simplify, you get 1.48. That's all. And this is how you calculate other values. And when you calculate other values, you get these values. When x is 0, y is 1, this was given. 0.2, when x is 0.2, y was 1.2, 0.4 gave you 1.48, and so on, so forth. So finally, when x is equal to 1, y will be 2.9766. So this was the question. So your final answer will be approximately 2.9766 when x is equal to 1. So this is how we do, we use Euler's method manually. We can easily do this in calculator as well. So we will explore today how to do this in a TI84 plus CE calculator and also Nspire CX2D calculator. So let's start with TI84 plus CE calculator. So this was your question. So out here, first thing we do is we will change settings a bit. So first thing you will do is you will go to mode. If you go to mode in your calculator, this is your mode. So in mode, instead of function, you will select sequence. So when you go to sequence, here is the sequence, just select it. Once you select the sequence, how will this look? When you press y is equal to or the function, this is how it will look. N minimum, un, u1, u2, vn, v1, v2, wn, etc. Right? Now what these things are, let's explore. Out here, u and v are two parameters that you need to work with. You can just ignore n minimum, w or anything else that you see here, just ignore that. What is un? Un is the recursive formula for x values. How x values are increasing? You keep adding 0.2 to the previous value, right? So this will be a recursive formula for the x value. U1 is the first value or the initial value of x, which was given 0 in this question. And Vn, V represents y values. So this will be a recursive formula for yn plus 1. And V1 will be your initial value for y, right? So when you fill in these values, this is how it looks. Now if you go back to the formula, y value is the previous value y plus h times dy upon dx on the previous set of values. So out here you see recursive formula for xn plus 1. It was the previous value of un minus 1. So yeah, for un we are writing previous value, that is un minus 1 plus 0.2. What is the initial value of x? This is 0. What is the recursive formula for y? It will be like this. So this is Vn, so we'll write Vn minus 1 plus h is 0.2 times dy by dx. This is given x plus y on the previous values. So un minus 1 plus Vn minus 1. And what is the initial value of y? This is V1. Once it is done, we have already done this, finished this question, completed this question. So next we move on to the list, table. Where is the table? In your calculator you will find table is here. So when you press the table, the blue second and graph will give you the table which is here. And if you see value when x is 0, there is an error because we are starting from 0. So first value is 0, when x is 0, y is 1. When x is 0.2, y is 1.23. Third value is when x is 0.4, y is 1.48. And if you carry on, when x is equal to 1, what is the value of y? Value of y is 2.9766, which is same as the value that you obtained in your manual method, right? So that's how we use TI84 plus CE graphing calculator to work out these values. Now, let's explore how do we use Nspire graphic calculator to work out Euler's method. So we'll do the same question. Suppose dy by dx is x plus y, y is 0 is 1. Use Euler's method with the step size of 0.2 to find an approximate value for y1. Now, in Euler, in TI-Nspire graphing calculator, open a calculator page and just type this command for the given differential equation. What is the command? Write Euler, a bracket. When you write Euler, you will find it is italic. The moment you complete writing Euler, it becomes a normal text. It means it is a command. So Euler, a bracket, dy by dx, which is x plus y, comma, your variables, x, comma, y, then x naught, y naught, x naught, y naught is 0, comma 1 here, target x is you to find the value of y when x is equal to 1. So target x will be 1 and the step size will be 0.2. So you write this command and just fill in these values. So how will this look like for this differential equation? It will be Euler x plus y, x comma y in curly brackets 0 comma 1, target x is 1 and step size is 0.2. So once you write this and enter, you directly get all the values. So corresponding to 1, value of y is 2.97664. So that's how we can use TI-Nspire CX2T calculator to work out Euler's method. There is one more method to find specific value of y for a value of x using TI-Nspire. So let's quickly explore that second method. Second method we use with the help of calculator page, and then we also use data spreadsheet. So first thing, what do we do here? We define dy by dx as x plus y. So this is a function. So first open a new calculator page and define this function fx comma y as x plus y and enter. Then you can also define h as 0.2. So once these two are defined, open a new list and spreadsheet page. This is how it looks. So in list and spreadsheet page, we need to fill in some values and some commands. First, you define your cells. So column A you can define as x values. Column B you can define as y values. Column C you can define as change. Now in A1 we write initial value for x. So which is, you can write x0 in case it will become, in this case it becomes 0. B1 will be your initial y value. So you can write it as y naught. Here in C1, you will be write the change in the y value. What is the change in the y value? If you recall, it is h times dy by dx at the given point. So you can write it as dy by dx we have defined as fx. So f of a1 comma b1 times h. Next set of values. So in a2 you write x naught plus h. y2, what will be the y2 value? y2 value will be the previous value of y plus the change. So it will become b1 plus C1. Define it as B1 plus C1. And what comes out here will be the change corresponding to new points. So what we can do here, you can just select C1 and just drag it, extend it. So select and pull down C1 to get values for this cell. Now how this happens, we will see in a minute. So let's explore this question again. Now again for other values, select A1, B1, C1 and pull them down, so you'll get other values. That you'll see in a minute. See. So this was your question. So first we define, then we start filling values. So first x values, y values and change. In A1 we put initial x value 0, B1 initial y value and C1 is f of A1 comma B1 times h and enter. Once you enter, value will appear. This is A1 plus h, so define as is equal to A1 plus h value, which will become 0.2. Second will be previous y value plus change, so B1 plus C1, that is 1.2. And for this, just select and pull it down. So this value will automatically be generated. For other values, select first three and just drag it down, down, down. These are all values. Now what do you need? The value of y corresponding to 1. So when x is 1, this is the value of y. This is what we got last time, right? So that's how we use Euler's method and that's how we solve it. Perform the operation manually using TI84 and Nspire calculator using different methods, right? So we stop here, and if you have any doubt or if you would like me to make any video on any other topic, you can reach out to me at jalajmaths@gmail.com. And if you found this video helpful, please like it, subscribe it and share it. And don't forget to press the bell icon so that you're the first person to be notified when a new video is released. Till we meet again, take good care.